Hi everyone, in this video, I'm going to be talking about entropy as is applied into, for example, deep learning or machine learning. Now, entropy has many definitions. For example, entropy in physics describes the state of order or disorder. So our universe have a natural tendency to go from a state of order to a state of disorder. So that right there is one definition of entropy. But entropy in this particular situation is defined in information according to information theory. So if you take a look at the Google Colab right here, well, first of all, right, we're gonna import the libraries that we're gonna need: NumPy, Torch, and neural network functional as F right here, so that we gonna perform the calculation of entropy later. So entropy in information theory measures the surprise or uncertainty about a particular variable. So like for example, X. So H is greatest when the probability is around 0.5%, and then least when it's closer to 0, 1. So when there's more predictability, then then H is smaller. And so when when you have a high H, which means that P is around 0.5 right here, there's more variability in your system. And then when H is low, there's more repeating data, so there's more redundancy in there. The formula for entropy is defined as the probability of event times the log of that event, and then you sum over all of the event that can happen in that particular model, for example, right there, right? The minus right here is because log of probability, which is less than 1, log of a number less than 1 is going to be minus. So you could want to have a minus and minus this one right here so that it become positive. Okay. There's also a thing called cross entropy. Oh, by the way, if you take a look at this right here, right, I'm using for Colab, I'm creating this cell right here using a text cell, and then here you see that there's the money symbol right here, and I'm using latex notation to generate this formula right here. So if you want, you can Google latex in Colab, or just latex, and put a question mark right there, and you can generate formulas like this in Colab. Now, there's also another definition of cross entropy between two distributions, like P and Q right here, right? So the cross entropy of the P and Q of the probability distribution P and Q describe the relationship between the two. So for example, if you have a model that is predicting a cat or not a cat, for example, right there, right? And then the prediction, deep learning prediction, give you a probability, some probability, right? Then you can do the cross entropy to mark the performance of the model Q in relationship with the P, which is a cat or not a cat, for example, right there. And the cross entropy formula is P and Q is P times log Q right here, and sum over all of the event. So taking a look at the implementation of cross entropy in Colab in Python. Let's say, right, if you have an initial list of point A and point 2, point A is occurring and point 2 is not occurring, the sum has to be equal to 1. And then if you run that, for example, right there, right, it's going to give you about 0.5. Now, if you, for example, change it to a probability of 0.5 and 0.5 right here, if you run that, you see that it has a highest number, entropy highest when P is closer to 0.5 right there. Okay, so let me change it back to 0.8 right there and run that. So now you see right here that so to calculate entropy in Colab, we're just going to go to a for loop and use this formula right here. Then go to the list. First is point A, calculate the entropy of that. Then point 2, calculate the entropy of that, and then add them together and print it out. Okay. Another way to calculate entropy is to use list comprehension right here, right? And then you sum over on the element and the list. So this one right here, just go to the list one by one, calculate the entropy for each particular element in the list, and then sum it over. And you run that, you see that it's still going to give you the same number. You can also write it out explicitly as the binary event right here. So here is a probability of occurring plus the entropy of not occurring. Add them together and print it out. Okay. To calculate the cross entropy, you can use the formula above right here, and this is implementation in Colab. Okay, so imagine here is a probability of a cat and not a cat right there, right? And then here's a model predict point A and point 2. So when you do that right there, you can calculate the cross entropy P and Q right here, P and Q. So it's going to go to the length, which is 2 right here, the length of the list, and let's calculate the cross entropy element 0 and then element 1 right here, and it's printed out the cross entropy right here. Finally, you can also do cross entropy in PyTorch right there, right? The first thing you need to do is you need to convert the ND array to the tensor right there, right? Because tensor doesn't play sometimes doesn't play nice with the order variable type. So when you convert it to tensor right there, right, you can put it in, use the function binary cross entropy right here. And then one thing you want to pay attention to is if you want to do PQ, right, you have to put Q first and P second like this right here. And when you do that, it's gonna give you the same number as the the one using NumPy. All right. This is a brief introduction to entropy and cross entropy in Python and Colab. Hope this helped you. If you like the videos, please give a thumb up, give a heart, subscribe, and have a good day.